Hello. Today, I'm going to teach you about probability.
So there I was, playing D&D, having a great time, and then all of a sudden, my dungeon master says, "Hey, would you like to attack the monster, Sasuke Uchiha?" And I said, there were so many choices to make. But then my brain said,
"Hey, Mr. C, it's me, your brain. You know, theoretically, you got a 1 in 5 chance of hitting this guy."
and then I said,
Wait, like, what do you mean theoretically?
Hey guys, brain again. Yeah, you know, theoretically, like, well, here's the definition. Basically, what it means is that it's something that we think is gonna happen. We don't know if it's actually gonna happen. We're just making a guess.
You mean like it's not even real?
here's what we need to know. There are two different kinds of probability. Theoretical probability, which is what we think is going to happen, and experimental probability, which is what actually happens after the event occurs. For example, if you're flipping a coin, you might expect half the time to land on heads, half the time to land on tails. That's the theoretical probability. But when you actually flip a coin 10 times, go ahead and try it. It might not happen that it's always 5 heads and 5 tails. Whoa, slow down there, Mr. C. Oh, what's this? A new challenger approaches.
Who's ready for a real cringy rap? I'm talking cringe rap supreme.
Here's a little story I got to tell about a new math topic that you know well. Theoretical experimental probability is a seed with the beat. It's a gift he gives to thee. First up to bat is theoretical. It's when you come up with a guess that's credible about what you think's about to happen.
Like I predict that your toes are tapping. Next to discuss won't come off as incidental. The other type of probability, experimental. After the event's done, you see what you got. It's the result, I guess it is not.
Probability goes on and on and on. Probability goes on and on and on. Probability goes on and on and on. Mr. C, when you're gonna end this song? Goes on and on and on.
When we last left our hero, a new challenger was just approaching. Show off. Luckily, we've got math on our side.
Yo, bro, it's Brian. I thought I'd share with you guys how I came up with the 1 out of 5 probability from earlier.
Now look, a little disclaimer before we get started here. I know that the book and basically any website that you go to that talks about probability is going to talk about dice. Now, I want to make sure that you guys understand that dice is just an example of a random number generator. And those are things that are used in all kinds of aspects of our life, like video games. I'll explain in a little bit, but let's first figure out how to calculate probability. So we're just going to focus on theoretical probability. And when you look at the formula, you'll notice it looks really familiar. It's the same kind of probability that we've been talking about for a couple sections now. It's the total number of favorable outcomes, or the things that we're interested in, over the total number of possible outcomes.
So when I look at something like a 6-sided die, and I'm looking at all the different sides of it, the total number of possible outcomes. My possible outcomes are 1, 2, 3, 4, 5, and 6, right? Those are my only possible outcomes. And if I were to say, like, be interested in the probability of rolling an even number. I know we've seen this before, but I'm going to go through it anyway. So my theoretical probability, now I haven't rolled any dice yet, right? So this is a theoretical probability. I'm making a guess at what's about to happen. There are, on my die, there are 3 favorable outcomes. 3 numbers that I'm interested in. 3 outcomes that I'm interested in. So that would be my top number of my fraction. My favorable outcomes are 3. Of my total number of possible outcomes, there are 1, 2, 3, 4, 5, and 6. There are 6 possible outcomes. So my probability is 3/6. Now for me, this is a totally acceptable answer. But if you go into like Big Ideas Math, they're going to be looking for the simplified version of this. So we have to simplify that fraction. We can divide both top and bottom by 3. And when we do that, we're going to get a simplified version that's going to be equal to 1/2. This is theoretical probability. That probability we've been doing for a while now, that's theoretical probability. The next thing we're going to look at is experimental probability, but that's not in this video. That's the next video.
And we're back for the fight of the century between Mr. C and Sasuke Uchiha. And I wanted to tell you guys how this kind of relates to video games, all this probability stuff. So, in a video game, your enemy like Sasuke here might have a defense of, let's say, 16. And for the coders, that means that they're going to code like a digital 20-sided die that kind of looks like this. And what they need to do in order to have Mr. C hit on his attack, that roll needs to get higher than a 16, right? So we have 4 favorable outcomes on this die. We have 17, 18, 19, and 20. There are 20 total possible outcomes here. There's 1, 2, 3, 4, 5, 6, 7, all the way up to 20. Anything above that 16 is a success. Anything below that is a fail. So when we look at that, we've got a theoretical probability of 4 over 20.
Bruh.
Or, simplified,
Bruh.
1 out of 5.
Bruh.
Alright, Brain. This is about to launch stack. I want to see if he hits. But then again, that's experimental probability. That's for a different video.